Okay, hi students. In this video, I want to complete the set 4, the first formula, and this is the last video that I posted was using substitution. This video I'm using without substitution, just using integration by parts. Integral u dv is uv minus u derivative and then the v. Okay, so let's see. Let's check it out. So let me call the first one I integral of square root a square minus x square and dx. So in this, if you compare this one, so this is u and this is v. So let's use straight away. So uv, that means square root of a square minus square, then the x minus integral, the derivative of square root of a square is 1 over 2 square root of a square, and then the derivative of the inside, which is minus 2x, so which I'm going to put right here, and dx. So far so good? Okay. Then this negative, I'm going to keep it as it is, because now see this 2 crosses out. So I'm going to take off this 2 right here because this is going to be 1, right? And there's one more x which I missed because of, correct? So it is u v and minus u prime v. So that's the actually integral of 1. So now this is dx. This x and this x gets multiplied will be 2. There's a minus. Now I'm trying to rearrange something here. I want to get a square minus x square in the numerator. So do some adjustment. If I want to write a square right here, you also have to subtract a square. Okay. And then put this in the parenthesis. So that looks exactly like the down part. And then we can use the formula. So 2 things are happening here. One thing is if I have a minus b over c, is a over c minus b over c, right? Then one more thing you also need to know is if you have 3 root of 3, this is same as root 3. It's always true. If I have a, the root of a is same as root a, because you can write this a as root a and root a. You can see this, you end up getting that. So we're going to apply this. So the first step is let's apply a minus b divided by c. So I equals, so x, I'll write x in the beginning, a square minus x square minus, and now I'm going to separate the integral to the first part, this one, this divided by that, so integral of a square minus x square divided by, and then this negative times this negative will be positive. So this will be a square, and it's a constant, so I'll write 1 over a square minus x square dx. Okay, so now this step I'm going to use this because it's the same thing inside. So I can write the top one as square root. So this is the square root of a square minus x square dx, applying that same idea. And this is a square times, and integral of 1 over a square minus x square is sine inverse of x by a, directly from the earlier integral formula, which is sine inverse of x by a. Integral of that is that, straight away, plus some constancy. And then you see this part is, in the beginning we said this is I, right? That's I. So this whole thing is I, right? So this is I. So it's like you're adding I both sides. So I will add I this side and this side. So this becomes 2I. This stays the same. And this will be plus a squared plus c, right? And then divide by 2 both sides. So this I goes away, and you end up getting, that's the integral I, right? That's the integral. The integral is that's it, see? X by 2, this one, and it's right here is x by 2. So that's how we can prove the formula using without substitution. One is last time I did with the substitution, this time I did without substitution. The next video I'm going to make is why the hyperbolic cosine inverse. Look at this. If you have square root of x squared minus a squared, why is this formula? So we'll try to prove that with the substitution in the next video that I'm going to make. Thank you for watching. As I said, it's always good to know how this formula exists. Why? What is the reason? So that's why I'm trying to show how it works. So thanks for watching the video. If you like the video, please like my videos and stay for the next videos coming up. Thank you so much for watching.